At Transport Canada, within the Oceans Protections Plan, we have been and continue to develop specific GIS tools that help us to sort, compile, and analyze large amounts of data that feed into decision-making processes. We have built and continue to build a suite of tools that are based around historical AIS data specifically for projects and initiatives involving management, planning, and resource allocation, such as the Emergency Towing Initiative. To create a solid base historical AIS dataset, we have fused the last 5 years, from 2015 to 2019, of terrestrial AIS and satellite AIS in and around Canada. This is joined with static vessel data that helps us to classify vessels by types and sizes. The first tool we are showing is called our Vessel Movement Density and Statistics tool. Products and analyses that are computed from this tool are used in multiple projects within OPP and TC at large. The tool creates independent vessel movements per vessel from positional AIS messages through time, like connecting the dots. This process is repeated from all vessels as recorded by AIS for each month per year. This is done in order to generate yearly and monthly vessel movements to perform further analyses. After this data is generated, we are able to see monthly or yearly movements from specific vessel types and/or vessel sizes. Using this tool, you are also able to generate descriptive statistics on the number of nautical miles being sailed per month for a given time period, say, from 2015 to 2019. The graphs and tables provide us with an understanding of how much traffic is in the area and by whom, along with important information on seasonality. The tool is also able to compute vessel density grids, which capture the estimated number of transits by vessel type and size, which give us an understanding of where vessel traffic hotspots might be for a given year. Information that is generated from this tool also feeds into some of our accident models that we have been developing, specifically our fire explosion, foundering, and hull machinery failure models. The second tool we are showing is our encounter algorithm, specifically ship-to-ship encounters based on ship domain theory. This tool iterates through historical AIS data and attempts to identify where and when vessel domains had intersected with each other. The ellipses represent the vessel ship domain. The size of the domain is dependent on the vessel size. The larger the vessel, the larger the domain. This algorithm attempts to identify in what we call a striking encounter. This is when one moving vessel's ship domain intersects with a non-moving vessel's ship domain. The algorithm stores all of the potential encounters within a database that can be visualized and analyzed after. The other encounter type that this algorithm attempts to identify is a collision encounter. This is when two moving vessels' ship domains intersect with each other. Similar to the previous vessel movement density and statistics tool, information from this algorithm will also feed into some of our accident models, specifically our collision and striking models. We look forward to discussing some of the other tools and models at a later date. Thank you for your time.